Okay, so I just want to do one quick example of the hypothesis tests for two proportions. It should look very similar to what we did the last unit with your proportions and your average testing, so there shouldn't be that much of a difference. The question I'm looking at is what's in the PowerPoint there. Group of individuals who wanted to quit smoking took part in a study. The sample is randomly assigned to take either a nicotine lozenge or a placebo lozenge. They were then monitored for a year to see if they successfully abstained from smoking for that year. The theory is that the nicotine lozenge will increase the chance of quitting and stay smoke-free. 459 were assigned to take the nicotine. 82 were successful. 458 took the placebo. 44 were successful. Run the test at 99%. So again, a lot of this is going to be the same. So the first thing you need to do is define and state your parameter. Now I have it as pi nic for nicotine and then pi p for placebo, and that should be stated when you write these out. Proportion of smokers who would take the nicotine lozenge and successfully quit. Proportion of smokers who would take the placebo and successfully quit. You could do this as just pi and have it be as proportion of smokers who successfully quit smoking. But somewhere along the way, you're going to have to define what the two groups are, the nicotine group versus the placebo group. So there are different ways you could write that out. I think it might just be easier to do it with two just statements here to get it out of the way. But there's my parameter that I defined. Next is your null and alternate. So I have my null being the proportion nicotine is equal to the proportion of the placebo group. Now it thinks that the nicotine group, the test is going to see if the nicotine group increased the proportion of people who successfully abstained from smoking. So I have pi nicotine is greater than pi of p. Next is our conditions, and we need to find p hat c. That's the combined p hat of the two groups, and that's what you're going to use to test your condition to make sure that these samples are large enough and balanced enough. So I have my conditions. They were randomly assigned. People were randomly put into either the nicotine or the placebo group. And then just doing the math quickly for the two groups to make sure all of them are greater than 5. Okay, so each one is greater than 5, so we're good to go. Now, I know last unit I had for the proportion was greater than 10. It kind of goes back and forth. 5 and 10, they both, depending on which book, textbook you're reading, it'll have either one. So usually as long as it's greater than 10, I know for the two groups they give you a little more leeway. Your groups do not have to be, your samples don't have to be quite as large as if you're doing a single group. We're using a propZ test for this. So I've named my test that I'm going to run. I then go to my calculator. The test statistic is 3.631. The p-value on your calculator, it'll be that scientific notation, a very, very small value where it has e to the, I think, the -4. I'm rounding that to 0, stating my alpha level of 0.01. So with that, you should be able to come up with the conclusion, and the conclusion should read something along the lines: with a p-value of 0, which is less than our alpha level of 0.01, we would reject the null. There is significant evidence to support the alternative. There is significant evidence to support the claim that the nicotine lozenge improves the proportion of smokers who successfully quit. Okay, so again, mostly everything looks exactly the same. Your format should be the same. The way you organize it should be the same. Make sure you're using the correct test, and make sure you keep your conditions straight, what you need to state to show that you are running a valid test.